During this video, I'm just going to go through the simple rules of differentiation. So differentiation is the process of finding a derivative or the gradient function. When given a function, fx, we obtain f dash x by differentiating with respect to x. And what we've been doing previously is we've been finding from first principles. So when we found the derivative from first principles of x squared, we discovered the fact that that was 2x. With x cubed, we discovered it was 3x squared. With x to the power of 4, we've discovered 4x cubed. And with 1 over x, or we can rewrite that as x to the negative 1, we discovered negative 1x to the negative 2, or negative 1 over x squared. What we see here is that there's a definite pattern and rule. So what we can state is if we give this in general terms and say that f of x is equal to, let's say, x to the power of n, then what we know is the derivative is actually equal to, if we just look at these numbers, so that's squared 2, cubed 3, 4, 4, negative 1, negative 1. So that's actually equal to nx. And if we just look at what's happening with the power, okay, it was 2 and now it's 1. It was 3 and it's gone to 2, 4 to 3, negative 1 to negative 2. So you can see there's a pattern there going down, so it would be n take 1. So that's our most simple rule of differentiation. What we also know is that if we have a constant, so in front of our x, so let's say in this case our function is equal to cx to the n, where c is just a constant, then when we differentiate this function, we're going to get c times by n, x, n take 1. So that's another simple rule of differentiation. We can also differentiate functions that have multiple terms in them. So when we're looking at functions with multiple terms, usually we might have the function f of x plus g of x. And I might just say this case is equal to y. Then the derivative, or dy over dx of that function, is f dash x plus the derivative of g. Okay, so these rules can be summed up in this table here, and we'll just go in to do a couple of examples just to see how it works as well. So during these two examples, we're going to be using the differentiating rule, x to the power of n, and we're also using differentiating a constant as well. So we'll just have a look at the first one. So the first one, it's constant times a function here as well. So our differentiation for this first one would become 5 times 3x squared plus 6 times 2x minus 3, and when we differentiate a constant, it becomes 0. So if we've got a constant in our function, then the number of terms will become 1 less as well. So 5 times 3 gives us 15x squared plus 6 times 2, so 12x minus 3. And in terms of this one, that's all we need to do there. When we look at this second example, the first thing we're going to do to make this easier is we're going to rewrite our fractions in with negative indices. So we're going to have 7x minus 4x to the negative 1 plus 3x to the negative 3. So that'll just help us when we use our differentiating x to the n rule. So then we'll look at the differentiation of that. So we'll have 7x just becomes 7. Here it's minus 4 times minus 1, x to the negative 2, plus 3 times minus 3, x to the negative 4. We'll just now go through and simplify this. So 7 still remains there. I've got minus 4 times minus 1 becomes plus 4. So x to the negative 2. 3 times minus 3 is minus 9, x to the negative 4. Now you can actually leave it in that form, or you can rewrite it so it becomes 4 over x squared minus 9 over x to the 4. But it's perfectly fine to leave it in that form. We'll just also have a look at an example now that uses square root signs. So here the first thing we need to do is rewrite that square root sign so that we've got it as written as a power of a half. 3x to the power of a half. And in this case we also want to get rid of the divide by x and write that with the negative indices. So that becomes 2x to the negative 1. When we now find the derivative, it's a lot easier to do this. So we still do, so it's 3 times a half. The process is still the same. X and a half, take 1 would be negative a half. Here, minus 2 times negative 1. X to the negative 2. So when we simplify, it becomes 3 to the 2, x to the negative a half, plus 2x to the negative 2. Once again, you can leave it in that form, or we can rewrite it so we've got no negative indices. So that would be x to the negative a half becomes over the square root of 2, so it would be 3 over 2 square root of x, plus 2 over x squared. Alright, and our function would be, derivative of our function would be simplified. We have a look at the second one, same sort of process as before. Get rid of our fractions, so write it with negative indices, so x squared minus 4x to the negative a half because it's over the square root. And now we can go through and find the differentiation. So x squared becomes 2x minus 4 times negative a half x, and negative a half take 1 will become negative 3 over 2. So 2x, 4 divided by 2 gives me 2, and I've got 2 negatives, so that becomes a positive 2x to the negative 3 over 2. And once again, we could write it without the negative indices. So it would become 2 over x to the 3 on 2. Alright, and obviously when we're dealing with fractional powers as well, we can rewrite them in slightly different forms as well. So this is the simple rules of differentiation. We'll continue to expand on these rules and use simple rules or processes for those solutions.